Hey 11s, hopefully you're doing well, staying safe, taking a break from the computer once in a while. Today we'll be covering exercise 4D, which is the second last exercise for chapter 4. Hopefully you guys are looking forward towards the holiday. We'll finish up chapter 4 and then hopefully we have some time to introduce the next topic, which is probability, before we get into the holidays. So exercise 4D is on circles and semicircles. I do want to focus on the idea of the circle being part of rather, it's relation. It's not a formula, function, in the sense that, remember, a function has to have one y value for every x value. Remember the vertical line test, where if I can draw a line through the relation and it intersects at two different points. So if I draw the line through this point, you can see it intersects there and there. That means that in our diagram given, it's a relation and not a function. So we have a circle with a general form of x minus h squared plus y minus k squared equals to r squared. Now h and k are very similar to our understanding from parabolas and whatnot. Instead of it being the turning point, our h and k values actually present our center. So the center value being h and k. We can also see that the value of r is going to be our radius. So just in case you're not familiar, radius means the distance from the center of our circle to the very outer edge. Obviously, given a circle, it's the same throughout the entire circle. So we've got this formula there, and we want to make sure we understand how to find the center. Just like with a parabola, because it's inside of a bracket and we're going x minus h or whatever it is, we're going to take the opposite of what's inside. So for example, if we've got, and I'm going to go ahead and write this for a random formula out, x minus 2 squared plus y minus plus 3, let's say, squared equals to, let's just say, 25. I know that my center, we're going to highlight these parts here where we've got minus h, over here, and over here we've got the minus k. Now, it has to be negative, the opposite, right? So our our center is going to be the opposite of whatever value we have there. So instead of negative 2, we have positive 2, and instead of positive 3, we have negative 3. And so our turning point, I don't know why I keep saying that, our center is going to be at the point 2, negative 3. So that's something to keep in consideration. Also very important to remember that the value at the very end is going to be r squared, not r itself. It's a very common mistake students make to misinterpret this as just r itself. Remember, it's r squared. And so if you're given that value, you're going to have to square root it. We'll get into that a little bit later. The next thing I want to look at is the idea of transposing. Now, if you were to transpose this equation from above, as in you expand it and then you try to get y by itself, you end up with this equation right here. The problem is, once you get to a certain stage, you have y squared equals 2, or the rest of the equation. And if you have that equation there, you realize that if y squared equals 2, blah, 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 you have to square root it. And if you square root that function there, or whatever relation is presented to you, if you square root it, you end up with a plus or minus. The reason is, and especially when you're trying to graph this in your calculator, you cannot graph a relation in your calculator. Instead, you're going to have to graph two different functions. One is going to be positive, one is going to be negative. And that comes from the square root of the y, that's that step there. And so we end up with plus or minus square root of r squared minus x minus h squared plus k. Now this obviously comes from just transposing. You can do this to any equation, any relation that's given to you in terms of it being a circle, and you will end up with a positive and negative outcome. So that gives us the whole circle, where the positive typically represents this top half here, and the negative represents this bottom half. So please don't try to type this whole equation, not this one, sorry, this whole equation or relation into the calculator. It won't really register because the calculator specifically asks for y equals to blah, 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 blah. Sweet, let's go straight into an example. I think it's very important for us to get examples and apply our understanding. You can see on the right hand side, before we jump in there, we've got on the right hand side, we've got this value of x, and in this situation, obviously you can see the value of r being our radius. Later on in the year, we'll look at the idea of this value here, where we've got the y value. So if I go up across there, I've got pick this point, I know that the y value is going to be that height there, but just keep that in mind before we move on. Okay, so find the equation of a circle which has a center of 3, negative 5, and a radius of 2. Now, for this one, we're going to apply our understanding from the original general form. I'm going to go ahead and write x minus. Now, instead of writing minus h, I'm going to write the opposite of what's inside my x value for this thing here. Now, our x value here is 3, and our y value is negative 5. So intuitively, we're going to write negative 3 squared plus y, and then instead of writing minus 5, I'm going to write plus 5 squared, and then ultimately in the end radius of 2. Remember, the radius is radius squared, at the end of the equation, not just the radius, so we need to write 4 or 2 squared, but 4 is preferable. Sweet, that's it. Now for the next two parts, we're going to go ahead and sketch the different graphs. So over here, we've got the relatively straightforward one. It's in that general form. So the first thing I'm going to go ahead and do is identify my center. So my center, and apologies for the terrible handwriting, my center is going to be 2, 1, both positive because inside of my general form the values are negative. And I'm going to also identify my radius. My radius is going to be, let's do it step by step, square root of 4, because this is r squared, remember. So the square root of 4, which obviously gives me 2. Now, you could argue it's going to be negative 2, but remember, that doesn't really exist. You can't have a radius of negative 2. The distance cannot be negative 2. Let's put this into practice. So let's go ahead and draw our axes. I'm going to go ahead and draw my axes on the bottom left. Try to do this as quick as possible, so you don't have to watch me graph Cartesian plane for too long. I've got my y and my x over here. Now I'm going to identify that my center is at 2, 1. So I'm going to do the obvious thing and just write 2, and then do about half. Let's say that's 1, and my center is right there. Easy. Now the next thing I know is that my radius is 2. Now you could go ahead and identify specifically where our x and y axes intercepts are. However, an easier approach to do this is to identify, well, if it was 2 units to the left, to the right, down, up, what would it be? Because that's the easiest way to look at this. Now I know that my y value is going to be, well, it goes from 1, and if I bring it down 2 units, it's going to bring me to negative 1. Now my x value hasn't changed, so I'm going to go ahead and label that as a negative 1 over here, and I end up with this point here, where that point is to negative 1. You do see the same thing happens when I pick this point there. I don't change the x value, I only change the y value. Oops, not that point. This point here, sorry. I don't change the x value, I only change the y value. Right now, that's y equals to 1. If I add 2, I go up by 2. That means I get the value of y equals to 3, and therefore this point here is 2, 3. I can do the same thing left and right. So instead of looking at it from the perspective up and down, I can say, okay, let's keep the y value the same and change the x value. Right now, the x value is 2. So if I move to the left, obviously it's going to go left 2 and end up with the value of 0. So we pick this point here, and which is going to be 0, 1. And then ultimately I can do the same thing on the right hand side. On the right hand side, move it 2 to the right, which obviously gives us the value of 4, 1. So the y value hasn't changed, but the x value has shifted 2 to the right. I'm going to go ahead and draw that circle. It's not going to be perfect. Good enough. So that's going to be our value where the center is going to be at that point 2, 1. Sweet. Now this is what happens when we've been given a circle or relation, that isn't in the form of the general form. Now first thing we have to do is actually identify what that general form would be. So I'm going to go ahead and actually rearrange the values so that I have my x values on the left, y values in the middle, and on the very right hand side, on the right hand side of my equation, I'm going to put the constant values. So I'm going to end up with x squared minus 8x plus y squared plus 4y equals to negative 11. So all I've done is I've moved these values, this value and this value. So I end up with that value there, and I've kept that there. And I've also moved the positive 11, there we go, positive 11 to the right hand side as well. Now from there, and I apologize in advance for those of you that completely hate this method, you're going to have to complete the square. So to complete the square, remember, we use the formula. So I'm going to go ahead and do that. If you need to go back and watch the videos for that, please do so. So we have x squared minus 8, and we're going to focus on that section there. X squared minus 8. So I'm going to rewrite that. I get x minus, now I write half of this value here, so negative 4. And I just take away negative 4 squared. Oops, that should be on the outside. There we go. So all I do is to take half of the value in front of the x, and then I take the that value there, and I take away that after I square it. I'm going to do the same thing on this side over here. So I'm going to use a different color just to symbolize that. Remember, if you end up with a negative value in front of the y, you need to make sure you use brackets. Okay, so we're going to end up with that, and I'm going to write, you know what, I'll use brackets just for argument's sake. End up with y plus 2 minus 2 squared, and put that in brackets as well. And then finally, I'm going to end up with writing minus 11. I'm going to go ahead and expand that bracket. Now in this situation, we can just get rid of those brackets. In most situations, you'd have to consider whether it's positive or negative. So after doing that, oops, sorry, I forgot the square there. Apologies if you can hear my dog barking in the background. So we end up with that. I'm going to go ahead and expand those brackets. So I still keep those x minus 4 squared. And then I write negative 4 all squared, which gives me negative 16, plus y plus 2 squared minus 4, which gives me negative 11. Rearranging that, moving all the constants to the right-hand side, I get x minus 4 squared plus y plus 2 squared equals 2. I'm going to add 20 on both sides. Well, that's because I've got the negative 16 and negative 4. Cancels out, gives me negative 20, which gives me a value of 9. Now that's our nice, very easy to understand general form. I'm going to identify my center. My center is going to be found the exact same way we've done the other values, which gives us a value of 4 and negative 2, because we take the negative of negative 4 and we take the negative of positive 2. And also know that my radius is going to be the value of 9 square root, or in other words, just 3. Sketching that value there, I'm going to end up with my center at 4, negative 2, so I know it's going to be in the bottom right half. There we go. 4, negative 2, let's say that's approximate. We end up with this value here. My radius is going to be 3, so that I know that my value of if I keep the x value the same and I go up in the y value, it's going to go from negative 2 to positive 1, which gives me this value here. So that's going to be 4, positive 1. And if I go down, it's going to be 4, negative 5. Remember, you're more than welcome to do the usual method of finding your x and y axes intercepts. They're exactly the same method as before. And then if I go with keeping my y value the same and moving my x value, I know that my y value stays at negative 2, and my x goes down from 4 to 3. So 4 minus 3 to give me 1. There we go. Which gives me the value of 1, negative 2. And if I add 3 to the 4, I end up with 7, negative 2. I connect the dots, and you should get an approximate circle. Lovely. Hopefully you guys have learned something from this. Best of luck, and let me know if you have any questions.